Well, howdy, y'all. Today we're going to be solving equations using trig identities. So why don't we go ahead and get started? Basically, what we're going to be doing is we're taking this equation and we're solving for theta. So why don't we get theta on one side and everything else on the other? So first thing I'm going to do is I'm going to divide by 4 on both sides, just like in Algebra 1. So I get cosine squared of theta is equal to 3 over 4. Now, being this is cosine squared, I'm going to take the square root of both sides because that's how I undo the square root. But when I take the square root, I have to introduce a plus and minus. And the reason for this is because a negative root 3 over 4 squared would still be 3 over 4. So now that I have this, I'm going to simplify it a little bit further. This is equal to root 3 over root 4, which is equal to plus or minus square root of 3 over 2. Okay, so now I've broken up my one equation into two separate equations, and I have the cosine of theta is equal to positive square root of 3 over 2, and the cosine of theta is equal to negative root 3 over 2. Now to solve these, I'm going to take the arc cosine of both sides, or I'm just going to figure out whose theta would give me a cosine of root 3 over 2. So I'm going to draw my triangles. For square root of 3 over 2, that's going to be in quadrant 1, and cosine is adjacent over hypotenuse, which would make this a 1 because it's one of our 30, 60, 90. Also in quadrant 4 because all students take calculus, so cosine is also positive in the fourth quadrant. That's a negative 1 down here and a 2. So theta, for cosine of theta is equal to root 3 over 2. Theta is going to be equal to, 30 degree, and that's 30 degrees, but it's below, so it's negative. It'll be plus or minus 30 degrees plus the period of cosine, which is 360 times n. And that n gives me all solutions because those would be coterminal to my solutions. Now let's go back over here and do the arc cosine of negative root 3 over 2. Well, I draw my triangles in the second and third quadrant because cosine is negative in the second and third quadrant. And this is a negative root 3 on the adjacent, 2 on the hypotenuses, and 1 and negative 1 for the opposites. Now, from here to here is 150, and from here to here would be 150 the other way, or negative 150. So that gives me my second set of solutions, would be plus or minus 150 plus 360n. Now, these two guys together will give me my answer for this question. And this question asked me for theta is contained in the set of real numbers in degrees. So I had to solve it in degrees. Okay, for number 2, I'm going to make a quick adjustment to this problem. Instead of a 4 here, we're going to make this a 1 because it makes the problem solvable, actually. So we're going to have the sine of x minus 1 is equal to 3 sine x. And just like before, we're going to have all our x's on one side and numbers on the other. So I'm going to go ahead and subtract over a sine. So I get negative 1 is equal to 2 sine x. So sine x is equal to negative 1/2. So I'm going to take the arc sine of the sine of x and the arc sine of negative 1/2, or I'm going to find the degree, or the radians, or the degree measures in between 0 and 2 pi that give me a sine of negative 1/2. So in order to do this, I draw my triangle again, and sine is negative in the third and fourth quadrants because all students take calculus. If you guys can't tell, this is going to be very important, and we've done this before. So it should be quite an easy notes for you guys. It should be easy notes for you guys to take. There we go. So sine is opposite over adjacent, or opposite over hypotenuse. So negative 1 over 2, negative 1 over 2. This makes this a root 3, and that a root 3. So this is pi over 6. So that reference angle is pi over 6, which makes this degree measure pi plus pi over 6, which is 7 pi over 6. So we have 7 pi over 6 and negative pi over 6. Now, negative pi over 6 is not in our interval, so we're going to convert negative pi over 6 into 2 pi minus pi over 6. It's 2 pi over 1, and subtract fractions, it'll be 12 pi minus pi all over 6, or 11 pi over 6. So my two solutions are 7 pi over 6 and 11 pi over 6. And those are the only two angles that'll give me a sine of negative 1/2 in between 0 and 2 pi. Okay, guys, last question. The sine of x times the secant of x is equal to the sine of x. Now you're going to say, well, Mr. M, we have x's on everything. I don't have any numbers. I can't move anything. Well, I'm going to tell you real fast. If you divide by sine of x on both sides to make this a 1, there's going to be problems because you're getting rid of solutions. And so never, ever divide by a variable because you will get rid of solutions and you'll just get the question wrong. So never divide by a variable. Only subtract and add. So what I'm going to do is I'm going to subtract that sine of x over to give me the sine of x, secant of x, minus the sine of x. Well, sine of x minus sine of x is 0. And what I'm going to do is I'm going to factor out a sine. I get the sine of x times the secant of x minus 1. And now, being this is equal to 0, I can set both of them equal to 0 because this entire left-hand side is equal to 0 when either the sine of x is equal to 0 or secant x minus 1 is equal to 0. So the sine of x is equal to 0. Well, what I can do if I have 0 is I can either draw a triangle that has 0 height, or I can remember to use my unit circle and remember that it's cosine comma sine. So sine is 0 here at 2 pi or 0 and here at pi. So this would just be pi plus pi n for using x. So for x. So that's one solution. And that's actually a solution that we would not have had we divided by sine. Okay. Next, we're going to solve the secant of x minus 1 is equal to 0. So I need to know when secant is equal to 1, well, secant of x is equal to 1 over cosine of x, which is equal to 1 over 1. I take the reciprocal of both sides, and I want to know when cosine of x is equal to 1. Well, cosine of x is equal to 1 only at one spot, namely it's right up here, or it's right over here at 2 pi and 0 again. So that would be x is equal to 0 plus 2 pi n. Because it's equal to negative 1 over here at pi, so that's not a solution. So now I have these two solutions, but really they're the same thing. Pi plus pi n will get me all the numbers that 0 plus 2 pi n. Because this guy will give me 0, 2 pi n, 4 pi n, and so on, all even numbers. Well, this guy, well, if n was equal to negative 1, it would be 0, pi, 2 pi, 3 pi, and 4 pi. And you see that every other one gives me one of the solutions from this guy. So my final answer is just going to be this. And when x belongs to the set of real numbers, that means I want a general solution. So on a quiz or a test or on your guys' homework tomorrow, if you see real numbers or a real number in degrees, I want a general solution. Okay, guys, I will see you tomorrow. Have a great evening.